This video is on factoring polynomials in a couple of different forms. There are a few different things that we'll be going over, and I will make that chunking clear as we go through them. And then I welcome you to revisit this video as you go through different things. I'll try to put highlights in at different points and different minute markers so that you can find your topic easily as we go through. Our first task is to factor this polynomial, and we notice that there are 1, 2, 3 terms. This is a 3-term polynomial. It's also to the 4th power here, so we called it a 4th degree polynomial. We're trying a 4th degree trinomial. And so we're going to first pull out a GCF, which is what we're working on our last lesson, and pull out a greatest common factor. In order to pull out a greatest common factor for these three terms, I'm actually going to look at each of them individually. And for the moment, I'm not going to include any of the signs. I'm just going to look at these as they're written. Okay, so 2x to the power of 4 is actually already factored. When I'm looking at variables, the cool thing about variables is that they're already in their prime factored form. It's the coefficients that I need to break down into their prime factors. So this number, 2x to the 4th, is already in its prime form. X to the 3rd here, I can't break down. It's in its prime form. It's the 2 that I need to break down. So 4 breaks down into a 2 and a 2. So this whole term then becomes, 4x to the 3rd then becomes 2 squared, x to the 3rd. Then with this 8, I've got a 4 and a 2, 2 and 2, so 8x squared becomes 2 to the 3rd x squared. So now when I look at these 3 terms, I can more easily see what their prime factor parts are. Now, so when I'm finding a greatest common factor, again, right now we're only looking at greatest common factor. We're not worried about least common multiple. With greatest common factor, I'm looking at what they have in common. So GCF, greatest common factor, is what they have in common. They've got a base of 2 in common. They've also got a base of x in common. Then I'm looking at what goes into all 3 of these. In other words, what's the biggest part that goes into all of them? So 2 obviously goes into all 3 parts. This one only has 1, 2 though. This one has 2, which includes 1, and this one has 3, which includes 1. So this 2 is going to be to the 1st power, or just 2. X has a similar idea. I've got x to the 4th, x to the 3rd. X to the 3rd is included in x to the 4th, right? And then I've got x squared. X squared is included in x to the 3rd. So the biggest thing that I can put in, the biggest thing they have in common is x squared. So that's my GCF, x squared. Now, the purpose of finding a greatest common factor is this is the thing that I'm going to pull out of all 3 of those terms. I'm going to factor it out. Factor is kind of a different word for divide in the sense that you're pulling this thing out. Now, the difference between factor and division is factoring usually leaves something behind. We pull it out and you leave the other parts behind. That's the difference between factor and division. So I'm going to make this a little bit smaller so I can see where everything came from, but also include, you see where everything came from, but make more space for the new one. Okay, so we've got all the same work. We still indicated that our GCF is 2x squared. So what I'm going to do in the next line is I'm going to indicate that I'm pulling 2x squared out, and then in parentheses, I'm going to have what's left behind. Now here is where some people are getting a little confused, and I think not all teachers will show this step, but I think This is definitely what we're doing in our head, but I think it might be a little bit helpful to see what's going on. So what I'm going to do is, in the same color, in these parentheses, I'm going to put the original polynomial, or original trinomial. So I've got 2x to the fourth. This is where I'm going to put those signs back in. 4x cubed and 8x squared. Now, what I'm going to do is divide each of these terms by the GCF. Okay, so when I say that I'm pulling a GCF out or factoring a GCF out, what that means is I'm pulling it out to the outside of the parentheses and I'm dividing each individual term by that factor, okay, or then by that term. So then what I've got left is 2x squared, and then I'm going to use my exponent and division rules to figure out what's left. So 2 divided by 2 cancels, and then x to the fourth divided by x squared is x squared. The subtraction stays. Then 4 divided by 2 is 2. And x to the third divided by x squared is the same as x to the third minus x squared is just x, right? So I can either use exponent rules or I can use simple cancel rules. They're the same thing in the end. So, and then here I've got 4. X squared divided by x squared just cancels. So my factored form, my final answer is the GCF, 2x squared, times x squared minus 2x plus 4. Now the way that I'm going to check myself is to distribute this GCF back in and check to make sure that I get my original trinomial there, right? So if I do the multiplication, I've got 4x to the fourth minus 4x cubed plus 8x squared. I'm sorry, I did the multiplication wrong. This is a 2. There we go. So this polynomial is the same as that polynomial, which means that I have factored correctly. Okay? So this kind of factoring is just pulling out a GCF. Let's look at another example of that just to make sure that all of the processes make sense. Okay, so I'm trying to find the GCF first, so I'm going to break down the coefficient parts. So I'm going to do 2 and 5, 3 and 5. So my prime factorization of these are going to be 2 times 5ab cubed, and this is 3 times 5a squared b squared. Then I'm looking for the GCF, and the factors that are included in both of them is, let's see, we've got a 5 in both of them, an a, and the smallest of the a's is a to the first. We've got a b, the smallest of the b's is b squared. So my GCS is 5ab squared. All right, so then I take the GCF and I write it out again. And then I leave space in the parentheses to do that division. Take the original polynomial. This one is actually a binomial. It has 2 terms. And the degree of this binomial is 4. Degree of this binomial here is 4 because if I add the exponents there, I get 4. This is also 4. The highest of 4 and 4 is 4. So this is a 4th degree binomial. Little side note. Now I'm dividing each term by the GCF. Okay. And so in my next step, just writing the solution. So 10 divided by 5 is 2, a divided by a cancels, this cancels and that becomes a 1, so I've got 2b, cancels becomes a 3, that just becomes an A, and those cancel all the way. So I got a 3A. All right, this is my final answer. Now remember, in order to check my work, I can just multiply it back out. So 5 times 2 is 10. B squared times B is B cubed. And then 5 times 3 is 15. A times A is A squared, B squared. And then I'm looking and I see that this and the original are the same, which means that my factoring worked. Now sometimes when we need to factor, there's more than just a GCF that will come out. We're actually going to factor into multiple different parts. So let's look at that in the next example. Okay, so here I've got a trinomial because I've got 3 terms, and the highest variable exponent on each of these terms is 2. So I've got a second degree trinomial or quadratic trinomial. Now, the way that we've been factoring so far is looking for a GCF. So I might try that really quickly. Just break these into their prime factor parts. And I notice that these 2 terms have 2's in common, but there are no 2's over here. These two terms have t's in common, but there's no t over there. So that means that there is no the greatest common factor is 1. If I pull 1 out, that actually leaves me with the same thing. So in this case, factoring using GCF doesn't do anything for us. So what we're going to be doing is we're going to be breaking this down into 2 separate binomials that multiply together to be this longer trinomial. There are lots of different ways that we can go about doing this. What I'm going to show you is something that's called the AC method. It's a method that will always get you the right answer. Okay, if this can be factored, the AC method will get you those factors, okay? It also includes something that's called factor by grouping, right? And factoring by grouping is its own discrete skill, so you'll use that sometimes even when you're not using the AC method, so it kind of teaches you 2 things at once. Now, as you become really proficient at factoring and you see that similar types of trinomials over and over, you're going to notice that there are some patterns that will keep you from having to do all of the steps. And we'll talk about that at the end of the video. All right, so what does this AC thing mean anyway? Well, if you remember back to when we were talking about lines, we talked about something called standard form. And you'll remember that standard form looked like y equals ax squared plus bx plus c, right? Where a was positive and a, b, and c were not fractions. So when I talk about AC form, I'm actually talking about taking the coefficient A times the coefficient C. So the first thing that I need to do is figure out what those numbers are in my original, in my original trinomial. In this case, A is 15 and C is 4. So I'm going to note that I've got A is 15, C is 4. And so in order to start the process of factoring this, I'm actually going to multiply A times C together. When I multiply 15 times 4, that gives me 60. Okay, so now with 60, I'm going to find all the factors of 60. One of the ways that I can do this, again, is by using prime factorization. For those of you who I have worked with before on finding prime factors, feel welcome to use that here. It'll keep you from dividing. I'm going to do kind of the old traditional method of dividing all the way through. But I do encourage you to talk to your classmates to look at the prime factor method or to come into office hours, and I can show you that. It'll keep you from having to divide and sort of guess and check. Now, I'm looking for all of the factors of 60. I know that 1 and 60 to go together. 60 is even, so it's divisible by 2. 2 into 60 is 30. 3 goes into 60 20 times. 4 goes into 60 15 times. I know this one because I just multiplied 15 and 4 to get 60. 5 goes in 12 times. 6 goes in 10 times. 7 does not go into 60. 8 does not go into 60. 9 does not go into 60, but 10 does. So I know that I'm done finding all my factors when the next number that I would write in this row in order is already represented on the other side. So you'll note that the numerical order of these factors starts here and then kind of makes a U going up, right? So if that U is complete, then I know that I've found all of my factors. Now, with the AC method, I'm going to be looking for, when I add the factors together, I want them to equal B. And in this case, B is negative 16. All right, so here's the first thing that we've got to notice. In order to get a negative number when I'm adding, I've got to have a negative number somewhere in the numbers that I'm adding together, right? So either one of them has to be negative or both of them have to be negative, right? But when I'm multiplying, I've got to multiply to get a positive number. Okay, so a positive number is either going to be a positive times positive or a negative times negative. This sign over here forces all of these to be negative, right? So if I want to add to be a negative 16, that means I'm multiplying a negative 1 times a negative 60 to get a positive 60. So I'm just going to add all these negative signs in there. And then I'm just going to check down. Again, I'm taking each of these factors, adding them together, and I want the pairing that makes this middle term here, which is 16. So you might notice really quickly that it's this one down here, but if you weren't sure, you could go through the motions. You can go through the motions of figuring it all out. So you've got negative 61, negative 32, negative 23, negative 19, negative 17, and negative 16. So this is the number that matches, which means these are the two factors that we're going to use for our next step. Okay? Okay. So for our next step, what we're going to do is we're going to take our original polynomial and rewrite it a little bit. Okay? So we're going to take 15t squared, and we're going to take the positive 4. Now this 16t, we're actually going to rewrite using these two numbers here. So I'm going to say minus 6t minus 10t. Okay? In other words, if I combine these like terms, I'm going to get a negative 16t. Okay? So all of this chart was just indicating to me how I'm going to rewrite this original polynomial so that I can start to factor. Okay, so now the AC part of this method is kind of over. There's the AC part. Now I've got 4 terms instead of 3. Okay, so this is where the factoring by grouping starts to take effect. So in order to factor by grouping, what I'm going to do is actually group these two terms together and those two terms together. And a grouping symbol is parentheses. So in parentheses, I'm going to put I'm going to color code this a little bit. I'm going to put 15t squared minus 6t. Then I'm going to add, oops, I'm going to add negative 10t plus 4. Okay, so I'm keeping the signs with the terms that they came with, right? So a positive 15t and negative 6t. Then I'm adding negative 10t squared plus 4t. Okay, so just grouping those together and those together. Now, within the parentheses, this is where I'm going to use my GCF, which is what we worked on the last sort of factoring. So in here, I'm looking for what is the biggest number that goes into both of these. So I can use, once you get really fast at this, really a lot of practice, you won't need to write it all out, right? But while you're practicing, you might continue to. So I'm looking at, I've noticed that I've got a t in common, I've also got a 3 in common. So I'm going to pull out a GCF of 3t out of those parentheses. And what it leaves behind is, it leaves behind 5t minus 2, right? So I'm dividing this term by the GCF of 3t, and I'm dividing this term by the GCF of 3t, okay? Okay, so then I'm going to pull a GCF out of this other term. So what I'm pulling out now, let's see, let's look, we've got 5 and 2, 2 and 2. So it looks like 2 is our GCF. Pull out a 2. And then I'm taking negative 10t divided by 2 gives me a negative 5t. So much for color coding. And then 4 divided by 2 is a 2. Okay. So now, what does this give us? Actually, what I'm looking for is to have inside the parentheses the exact same thing. Right here, what I notice is that I've got a positive 5t and a negative 5t, a negative 2 and a positive 2. So if I pull a negative out of this, I'm going to have the exact same thing in parentheses there. So I'm going to go ahead and do that. I'm going to rewrite, everything will be the same, except for, I'm going to make this a negative right there. Okay? So this all stays the same. 3t, parentheses, 5t minus 2, that stays the same. Now I'm changing from a positive 2 to the negative 2 outside, and if I'm pulling a negative out, that changes these signs here. Okay? So what I notice is in parentheses, I have the exact same thing. And outside the parentheses, I've got the GCFs. So what I can do is take one more common factor. This parentheses is actually a common factor. Do you see that? You've got 3t times this thing. I've got 2 times this thing. These two things are the same, so it's a GCF. So I'm actually just going to pull that whole thing out. And what that leaves behind is 3t minus 2. Okay? And this is my answer right here. Okay? All right. So what did we do? We took this original polynomial and our goal was to break it into 2 binomials here. There are lots of different ways to try to spin through numbers and figure out what to do here, and you might have a quicker one. What I'm offering to you is a method that will always get you the binomial if this thing is factorable. That way when you run into some numbers that are a little bit tricky, or you're not sure if you've exhausted all of your options, this is a method that will get you a solution. Okay, so what I did was then I took A times C, 15 times 4 is 60. And then I listed all of the factors of 60, 1 times 60, 2 times 30, etc. Then what I did is I added all of those terms together. -1 times -60 is -61. And did that all the way down. I compared these to that B term, which is -16. Because it's negative, I knew that both of my factors needed to be negative over here, right? And I noticed that -6 plus -10 is -16. That's the sum that I was looking for. Once I have this information, I can rewrite the original polynomial here. So -16 becomes -6 minus 10t. Okay, so then I applied some grouping. I put the 15t minus 6t in parentheses plus the -10t plus 4 in parentheses. From each of these parentheses, I pulled out a GCF and did the division. Pulled out a GCF and did the division. Now, in order to complete this problem, I need to have what's in parentheses be the same exact thing. And there was a problem in the sense that I had a positive, negative, negative, positive. So I noticed if I pulled a -1 out of here, it would switch these signs here and there so that my two parentheses are the same thing. Once I have the same thing in these two parentheses, I pull them out here, leaving behind the 3t and the -2, which gives me my factored form. This method right here is called factoring by grouping. Okay, so in class, we're going to have a quick video quiz on this, and then we're going to look at some special cases for how we can make this factoring a little bit faster if we notice particular patterns. If you're interested in doing a little bit of practice to see if you've got it, you can look in sections 4.5 and 4.6 in your book at both examples and some practice problems to see if you're on the right track.